Alright guys, welcome back to the channel. I know it's been a minute since I post something for the Grullón DDR GT8e. I'm being busy at work. Some unexpected problems arise, so I gotta take care of those issues too. All the projects that I got working. So, but anyways, we're back in business with the Grullón. So for this episode, I'll be showing you the design and build for the Gear Selector. So without further ado, let's get into it, guys. Alright guys, so here's the gear selector that I'm using. So if you see, you got all the buttons. So you got the parking, if you see the R for reverse and the little arrow, so it's this button right here. You can see right there the neutral drive. I'm not using this button even when I program it to do all-wheel drive or two-wheel drive. It is programmed and all that, and I'm not using it. And then the parking for the e-brake, I'm not using this button as well. So I take this unit from Acura. I don't remember exactly the model, but if someone is interested, I can put it on the comments and I get back to you. And this is the control board that goes over here on the back. So if you see these little things like this one that fall, it got those little fingers to take care. I mean, when you actuate from the other side, they slide and they slide here, so they make they complete the circuit and do whatever is commanded to do. So I try to use this board, which is the original one, but I was expecting like tactile buttons, but there were no tactile buttons, so it's just this mechanism. So I reverse engineered this to do something, that I can fit on my stuff. So here's the software that I use to design. This is KiCad or KiCad, whatever you want to call it. So this is the LED board, and I will go over that with you in a minute. And this is how it looks. So I did all this. I sent it to a company to take care of that. So also here there are two boards. They are identical in the shape, but they are, the components are different. So this is the controller, and we're going into this in a minute. But just to show you how I did this, so that's the schematic, and here's the board, the way it will look. So we go over that in a minute. So this is the prototype right here. These are the tactile buttons. Like I said, I'm using this to represent this. I'm testing. So you got parking, reverse, neutral, drive, and the e-brake. And then the last one that is over here, I'm not using it, which is the all-wheel drive or two-wheel drive. So you got a few LEDs over here. You got two LEDs, but one of them is three color, is RGB, and the other one is a single color. So with the first LED, I think it's blue, red, and green. So I'm using blue to represent that it's in parking, and red, and you will see the colors later. I'm not exactly. I don't remember exactly the colors, but that's what it is. Then I got the slave. This is a controller. This is an Arduino Micro that I'm using. And then the Arduino will take the input from here. Will generate some signals to, this is indicators, because this thing right here, if you see, it got holes. It got some holes and some plastic like to focus the light. So then you will see these, they look white, but they will be lit in whatever color I chose to. So these LEDs will do that. That's an indication. Then these other LEDs are for indication only. For the prototype, I'm not using those, and then those signals will go to this relay board and send the signal for the reverse or forward. Also this for each of the units, for the front power unit and the rear power unit. And then the e-brake. Okay, so here you have the master, which is the one that will display everything on the cluster, that I will show you that in a minute too. So that's what it is. As soon as I put power, you will see how this will work. So it will go automatically to parking and engage the parking brake. So this LED right here represents the parking that is activated or deactivated, and then the other LEDs correspond to forward, reverse, or neutral. So let's give it power. So let me tell you something else before I get power. This will represent, this is a power supply, a 12-volt power supply. This will represent my 12-volt battery. Then I got this thing right here is a DC converter, so it converts from 12 to 5 volts because this system works on 5 volts. And let me provide power now. So if you see, once it got power, it enters on parking because that will be the default. And then you got the e-brake is activated. It's supposed to be activated when you power down, but just to trigger again. And here are the buttons. So right now I'm on parking, so that's why it doesn't do anything. So now if I do over here, you see it change to green. That means that it's in reverse. And you see the other LED that is activated on the module, that is sending the signal to both motors to go reverse. Then neutral, you see that it changed to red, and then you got another LED somewhere over there on. I mean, you don't have any LEDs because it's in neutral, so you're not sending any signal. Then you can do this is drive. So if you see it changes over here, that's the LED, and again this is just indication, it won't be there. And then you got another LED sending the signal out, and you know, so the emergency brake, the e-brake, will be energized automatically when I go to parking. So watch this. So right now it's supposed to be going forward. So if you see, it engage immediately. So if I'm on neutral, that's the only way when I can engage the e-brake if I want to. This button is a little bit flimsy, but if I press it, you see it took it. So right now, and if I go to another gear, let's say that I'm neutral with the e-brake engaged, if I go reverse, it will turn it off automatically. So that's basically what it is. And again, this guy right here, these Arduino Omega, is the one that will be via Ethernet, via USB, is communicating with a small PC that I will work with later. I'm doing all the development here, so my gauge display is here. So let me show you real quick. So right now it will indicate that it's in reverse when he do his thing. So if you see at the corner, it says that it's connecting because I got this cable disconnected from the PC. So now I connect it, and it will you see that it got reversed. And you know, if I put it here, I will press my parking button, so you will see. So it goes to parking, and I don't know if you hear the relay clicking. So reverse again, you hear clicking, then neutral, and then drive. So and that's I'm working on this. So eventually this will be displayed on a 12.1 inch small screen, and it will populate, you know, the speed and all that kind of stuff that everybody likes. So another thing that I would like to add, you know, this blue cable is Ethernet, and I'm using I2C protocol to communicate between this slave and the master. And if you're a savvy on this protocol, you know that this is I2C, means, well, integrated circuit communication. That's what it means. So the distance is supposed to be short, like in centimeters, but if you control the capacitance between the cables, you should be able to accomplish longer distances. And right now I have here like 25 feet. So if you see, goes from here to here. So in order for me to do that, I use this twisted pair. So I use ground that is twisted with the SDA, which is one of the signal, and then I got the same with the clock signal. So that way I minimize the capacitance between the two signals, and then I'm getting rid of any electromagnetic interference. So that's what it is, guys. So next step is to assemble the boards when I get them with all the components. So